Assalamualaikum, my name is Daniel Ahmad Hafi bin Syarul Anwar. I'm from class 4X BAV1. So today I want to present to you about my assignment, which is temperature sensor. So firstly, I want to explain to you how LM35 temperature sensor work in this project. The LM35 sensor measure the temperatures and give us the voltage and converts to the temperature in Celsius. For every 1 degree Celsius increase, the voltage increase by 10 millivolt, which means 1 degree Celsius equals to 10 millivolts. And if it's 2 degrees Celsius, so the millivolt will become 20 millivolts. It increased by 10 millivolts. So next, I'm going to explain to you about millis function and why it's used in this project. In simple term, millis is returns to the number, which is milliseconds, which means thousands of a seconds that have passed since the Arduino was powered on or maybe reset. It helps to track time without blocking the program from doing other tasks. So in this project, we're using millis to manage two main things. One, read temperature at regular intervals. We want to read the temperature from LM35 sensor every 1 second, which means 1 second is equal to 1000 milliseconds. Instead of using delay, we're using millis is more preferred, because when we use delay, it will stop everything from running. So we use millis is to allow the Arduino to continue doing other tasks like checking the buttons or blinking the LED and so on. And number 2 is non-blocking LED blinks. We also want to make the LED blink without stopping the rest of the program. If we use delay, the LED would stay on for the entire time and the Arduino is waiting for other tasks. Using millis, it let us to blink the LED in intervals while still allowing the rest of the program still run normally. So this is how I connect all the components on breadboard. So that's my circuit. What I use in this project is LM35 sensor, an enable button, LED, and Arduino UNO Board. So now the system is still disabled because I didn't push the button yet. So when I push the button, the temperature is reading. So now the temperature is around 25 degrees Celsius. So nothing's happened. When I touch the temperature sensor, the LED will illuminate because the temperature is increased to 45 degrees, 44 degrees, means it's above 30 degrees. So when it's above 30 degrees, the LED will illuminate. So when I release the temperature sensor, the LED will shut down and the temperature will decrease back to normal. So this is the modified version of the previous coding. So this one is to make the LED blink. So now the temperature is already, now the system is already on. The temperature is still normal, around 24, 23, 25. So nothing's happened here. So now to make the LED blink, it need to above 30 degrees. So I touch the temperature sensor and now the LED is already blink. Alright. So in question 5, what I need to do is just add on this things are just display on the serial monitor, which I already set. It will say warning high temperature. So now the system is disabled, so I'm already on, and then the temperature is now 21, 22. Yeah, so as usual, it's still normal. And when I touch the temperature sensor, the LED blink, and now on the serial monitor it says warning high temperature because it's above 30 degrees Celsius. Alright. So this coding I already modified. I add on the potentiometer over here to adjust the threshold. So now I need to on the system first because the system is disabled. So now the system is on, the LED blinking because the threshold now is 38. I can lower the threshold. Now the threshold becomes 25 degrees Celsius, 28, 32, 33, 34, 36, 40, 43, and now the threshold is 50 degrees Celsius. That's the highest. So when 50 degrees Celsius is not illuminate, so the LED not light up. So when I lower the minimum that I can go, it's 40. Now 40 also it's light up. So that's the use of the potentiometer. Yeah. Alright. Now back to normal. Okay, so in our project we use something which is called millis instead of delay. Now I want to show you why milli is more better than delay. Delay stop the whole program for set times. Like for example, if we write delay 1000, everything just pause for 1 second, which means 1000 is 1 second. During the time, Arduino can't do anything else. So but with milli, they don't pause the program. Instead, they just check the time and only do something when the right amount of time has passed. So this is super useful for the Arduino users, and they can do Arduino can do many things at the same time, such as blink the LED and at the same time still check the temperature or read the temperature. So milli it's help more better and smarter for Arduino project. So this is the upgrade version from the previous coding. This is to add buzzer, such as question 9. They say need to add buzzer in the coding, so I add one buzzer in the coding with threshold above 35 degrees Celsius. So now the threshold is 35 degrees Celsius, but the temperature is 43 degrees Celsius. So the buzzer is buzzing and the LED is blink. So that's all. So this one is the modified coding. This one, the project is to show and when the temperature is above 30 degrees Celsius in 5 seconds. After 5 seconds, and then the LED will light up. So if 1 second, 2 seconds, it will not illuminate. So here's the temperature. The temperature is normal now, it's 23.5. So now the LED is not pop up. So I'm gonna touch the temperature sensor, and then wait for 5 seconds. So okay, 1, 2, 3, 4, 5, and then baru dia menyala. So let the temperature cool down first. So now the temperature is cooled down. So now I'm going to touch for 5 seconds. 1, 2, 3, 4, 5. Okay.